Welcome to the Glassworking shop. Well, I did a bunch of prep over the last couple of days, making some of my striped solid core slabs, and I didn't bother videoing this because I've done it so many times on so many videos, but decided to make a video today because I'm going to be doing something a tiny bit different that I've never tried before, and we'll see how it comes out. Going to be using the squeezer, and normally I make triangles and hexagons, but today I'm going to try some square experimentation, sticking a bunch of my slabs together. And here's, get the GoPro here. Possible to see on the camera, but I'm going to be using some blues and greens, and I got a bunch of slabs all stacked up in the assembly fixture, and I'm going to try to press them together. I'm going to put the assembly fixture in the kiln, preheat it, stick the whole thing on a big punty, then put it in the squeezer and try to squeeze it into a square shape, and hopefully, if I'm lucky, all the air will squeeze out, but I've never tried squeezing slabs this way, so who knows, might work, might not work. And then once I have a square, I'm going to mush it around and distort it with a variety of other dyes and see what kind of an interesting shape I can get as the glass flows the way the glass flows. So this is one direction I'm going with my experiments. Another direction is to try to do geometric perfection using precision cold work to try to get patterns that are geometrically accurate. But it's also fun to let the glass do what glass does. Glass flows when squeezed and sometimes produces interesting and unexpected patterns. So this one is going to be an experiment in squeezing and flowing and seeing what happens. So into the kiln it goes, and see you later. Okay, I think everything's ready. I got the cameras going, I got the parts all hot, kiln is ready, setup is ready. Let's see if we can make this pig oink. Let's see, the first thing I'm going to do is going to prepare my punty and my puller. I've got one that I used for other things, and so kind of preheated the end a little bit in the kiln so that it don't explode. In the last video, I kind of commented on I should get better at preparing. Think things through, have a plan. So, trying to get better at preparing. This thing was originally a triangular puller, and it's probably not going to take too much effort here to heat it up and squeeze it into a square shape. I've got the squeezer set up. Rotate it around a little bit. Got the squeezer set up with the square iris style dies. And as I've mentioned before, the iris dies are great because they'll squeeze any size, and the only downside they have is that they introduce a little sliding distortion, but this particular thing that I'm making today is a kind of an experiment in seeing the glass flow, and it's not required that everything be geometrically precise with no distortion. In fact, it's entirely possible that the sliding distortion might even result in something cool. Who knows? Part of the interesting thing about this process is being surprised by how the material behaves, and instead of trying too hard to control the material, just kind of letting it do what it does. So that's going to be the puller, and then this is going to be the punty that I build the thing on. Some of the kiln dust off it. And kind of get this guy a little bit preheated and a little bit ready. Got to prepare in advance. Little bit by little bit, I'm getting a little better at this, of thinking ahead and planning, but you know, sometimes you just have to react. You have to react to what happens at the time and just be prepared for whatever happens. Probably don't need to clean that end. It's just a punty, but okay. Squeezer does a very, very nice job of quickly making a square thing out of a blob. So let's get Mr. NQALHA out of the way, and then oh so carefully, because I don't want this thing to end up on the floor, get my, oh, this is scary. I'm probably going to design a more stable transfer mechanism because this thing just slides around way too much. So it's been preheated, and now I'm gonna just heat up the end of these slabby pieces and just weld on some clear. I'm going to weld quite a lot of clear onto this end. Try to make it as stable as I can. This process, once everything gets tagged together, all is well, but while it's still in the unstable state, it's a bit tricky. So, there we have a nicely welded big-ass blob of clear. And you notice that the stack of slabs is not really square, it's really rectangular. And that's by design, because I want to see what happens as they squeeze and distort and flow. This is not intended to be a precise square design. It's intended to be a little bit flowing. So here comes the scary part. At this point, everything is super unstable, and I gotta work quick before it all goes to hell. So I'm going to be welding the outside edges. I don't want to weld the face because I want to give the air a lot of good gaps to escape from. And if I welded up the back face, then there's even more chance that I'm going to be trapping air. So here we go. Gonna heat this thing up in the far flame. Hopefully it won't explode. Get this hot guy out of my way. Once I get it tagged together, I'll be a little bit happier, but at the moment, this is a scary place to be. So, got the 65 millimeter Herbie running pretty much wide open, compressed air wide open. My oxygen system is a low pressure tank, 175 psi low pressure tank, in combination with 2,000 psi high pressure tanks. And so it gives me, and they're connected together with a check valve system, and so it gives me the ability to rage like this for a short time, which could never be supported even slightly by the 3 5-liter per minute oxycons. But because I have the high pressure backup to handle this extreme requirement, I can actually get the best of both worlds out of this system. Of course, I can't do this for very long, but I don't believe I need to do it for very long. So far, so good. It's not exploding, it's not collapsing. And Gotta keep that the attachment, the moil hot, because if I don't, it'll fall off. And that's why I really like this giant ass flame. It covers more area. So everything's looking very nice, looking under control. I'm gonna switch to handwork here. And then very gently and carefully gonna get it ready for squeezation. You don't want to crack it in the squeezer. Just very gently. As gentle as I can be. Of course, once I get going, I'm just going to squeeze it like crazy. But in the early stages, gentle, gentle, gentle. Let it tag, get it stable. Things are looking good. The early stages of squeezing are the most difficult. The piece is unstable, in great danger of collapse. And I gotta be very, very careful. The punty end is a little bigger than the rear end, so I gotta kind of correct that before I can get any more going. And it's actually kind of nice to be able to start squeezing the air out from the sealed end and squeezing it out toward the open end, so it's actually kind of convenient that things have worked out this way. So now I'm standing on it. Now that is looking a lot better. Starting to get a little droopy, which is a really good indication that I'm starting to build core heat. And then obviously the outer layers are getting hot first, which means that I'm going to be getting my tagging and my fusing on the outer layers first, and the inner layers will take the longest time to fuse. Things are looking very good. I'm very, very happy so far. it back in the NQALHA. Let it run just a little bit, let it build up some core heat. I'm no longer in danger of catastrophic collapse. Let me check this over here. Yep. No longer in danger of catastrophic collapse. Now it's just a matter of building up some core heat. Getting it all fused together, seeing how happy it is when it all flows together. And then once it's in a square shape, that's when I start getting crazy, because this thing ain't gonna stay square. It's gonna get squeezed but good. I tell you, I say, this thing has some squeezing in its future. That's the fun thing about the squeezer project, is that it's not only inventing a tool, but it's inventing the glassworking techniques that use the tool. And as more glassworkers have an opportunity to use the tool, I'm really looking forward to seeing what are they going to invent with this thing? What kind of techniques are going to be invented with the squeezer? I can also see the possibility of other inventors, other craftspeople and creators inventing a variety of die shapes for the squeezer. I can see a whole creative universe of pattern dies and shaping dies. I can even imagine blow-in dies for hollow work. I can even imagine this being used in soft glass for blow-in dies. And it looks like there are so many possibilities for how this squeezer can be used. Exciting times are definitely ahead. It's definitely drooping. I can see that it's forming into a nice square-like shape. Now, when it's drooping like this, I really can't use the NQALHA. This really requires handwork to control it at this stage. Okay. I noticed that it was getting a little bit thick on the ends and thin in the center, and so when I put it in the squeezer, I applied a bit of downward force on the puntee. This is actually looking very nice. It is very, very close to being ready for the next step in the process. Kind of focusing on the moil here. Make sure that I've got a really good solid weld that isn't going to come loose in the next operations. Okay. Boy, that is looking good. I tell you. I'm continuing to do my internal accounting to try to figure out how much it cost me to make a squeezer, and then figure out what I can reasonably sell it for. It's a surprisingly complex project with a lot of parts. So, unfortunately, I don't suspect that it's going to be cheap. And I do realize that a lot of glassworkers don't have a lot of money. It's a sad fact, the life of an artist. Very, very few glassworkers have lots of money. But at the same time, I can't give them away. My shop is expensive to run, it's expensive machines, lots of cost involved in running a machine shop, so it's going to be a difficult decision to figure out how to properly price this guy. So that, boy, that's looking nice. That is nice and square. Boy, look at that. That is square. I tell you, we got square going here. So I'm going to leave it up there to cook a little bit, and then squeezing dies can get hot, and so never just grab squeezing dies if you don't know what they've been used for. They can get very hot. So I'm switching now from the iris dies. I'm going to be switching over to the fixed dies using the quick disconnect feature of the squeezer. I'm going to be using the 1/8" radius dies. I'm going to squeeze a kind of like a 4-leaf clover kind of pattern. See how they squeeze like that? I'm going to be squeezing that. So, actually, try to reclaim some of that core heat. Glass is all about timing. It has its own schedule, and the best that a glass worker can do is to work on the schedule demanded by the glass and understand what the glass is trying to tell you, because in this business the glass is the master. Or at least that's the way it seems to me at my current skill level. Okay, 65mm Herbie running full on from tanked oxygen from my 3 reserve tanks that I pump up overnight with the home fill, pump up to 1,000 psi in a bank of 3 reserve tanks, so that when my low pressure system can't handle it, and obviously this is way more than 15 liters per minute, when my low pressure system can't handle it, I've got the high pressure reserve. So just soaking in the heat, starting to see a little bit of droop and twist, which means time to switch to handwork. Trying to be careful to avoid too much elongation. The squeezer dies are 4-inch, so the piece is getting reasonably close to the limit of how big the dies can handle, so I'm kind of using a little gravity here. To try to keep it from elongating. Trying to drive the heat into the core, and that's why I'm kind of marbering a little on the outside to keep the shape under control while I'm driving the heat into the core. Still obviously haven't perfected this, since this is one of the first times I've done it. And exactly how loose and floppy does it need to be? How hot does the core need to be? How do I judge core heat? I don't know. Okay. I'm going to try to center this guy up properly. And then first squeeze didn't do very much, which is fine. I've got guides, I've got my divots that will guide the next operations. Try to keep the squeeze on center. I'm not trying to do too much too fast. Standing on it, letting it move slowly, starting to get the pattern forming. This is my first attempt at a large solid piece on the Herbie, and in the past I used the Delta Mag for all of my large solid work. I'm just giving this a try. I'm thinking about designing a quicker disconnect system so that I can more quickly and easily switch from the Herbie to the Delta Mag. Although Herbie seems to be holding up pretty nice doing this. As I'm building up core heat, I don't want to totally overheat and blister and destroy my outer layers. Standing on it. See how much force I can generate. Looks like I'm still doing pretty good on my high pressure oxygen. I'm using a home fill to pump up my high pressure tanks, and I've read that home fills are happier when they only pump up to 1,000 psi. So I have 3 high pressure tanks. connected together with high pressure hoses. And this allows me to pump them up to 1,000 but still have the equivalent volume of a single tank pumped up to a much higher pressure. Definitely getting some floppiness going on. And that is going to be the pattern. So now the next stage in this experiment I'm going to move the NQALHA into striping mode and take a piece of marine that I made off camera. This is a small diameter bullseye, and I'm going to put some stripes on it in those divots that I just created. Maybe I'm not. Nope. Nope, it's not going to work. So, plan B. I'm going to just put on some color. I've had success in the past striping with my marine pieces, but only if they're thinner. And I certainly don't want to preheat the piece in the kiln. I wouldn't be able to hold on to it. So this was plan B from the beginning. So I kind of suspected that I might have that problem. I have had great success striping with my marine rods if they're smaller diameter. And yes, that one was annealed, but still, it just was not happy. Just trying to make sure the piece stays hot. Cold glass is not happy glass. Kind of don't really have a planned out, worked out design. I talked in a previous video about how I'm starting to document my designs. When I'm doing just wild-ass experiment, I don't take the time to do the documentation. And this is just a wild-ass experiment. If I learn something from the experiment, hopefully something good, hopefully not just another way to fail, then I'll take what I learned from the experiment and do a little bit more carefully planned and carefully made step 2. But at the moment, this is just wild-ass R&D. Hey, let's see if this even works at all. So the end product that I'm going to be producing here is going to be round. So my next step is to round it up, pull it down, see if it actually comes out cool. Hot work in the hot shop. I'm gonna go get the welding gloves. This is getting hot. Using TIG welding gloves, I find that they give a lot better dexterity than the Kevlar gloves that are commonly sold for glasswork. And no, leather isn't as fireproof as Kevlar, but hopefully I won't need fireproof. Periodically reversing direction to try to keep the twist under control. And of course, in the beginning of the video, I talked about preparing in advance, and I just realized, oh yeah, for all that talk about preparing in advance, I made a square punty for a round object. Duh. It'd be very interesting to see how this looks. Whoa! First time I ever cooled a graphite paddle in water was really a shocking experience. I thought, is it gonna explode? Starting to get some droopage going here. Part of developing technique for the NQALHA is to figure out how to manage droop on a single-sided lathe. manage group, how to manage twist. I'm not sure the twist is really a big problem in this piece. Just reversing direction. A little bit, trying to refine the thing into a somewhat roundish kind of shape. I do have some guidelines to help me keep it under control. I think it's probably impossible to totally control twist using this method. I think the only way to get a really twist-free object is either with very synchronized hands or a real lathe. But like I said, I don't believe that this piece requires a complete absence of twist. But hey, it's all R&D. Looks like I got some kind of weird little bubble breakthrough thing there on the surface. I am not going to let it bother me. Have little or no idea what's going on the inside of this thing. See if I can do something about those weird little bubbles. I don't know. I may just be causing myself more trouble. But hey, it's all R&D. I'm not sure that was worth it. All I ended up doing is putting giant divots where little bubbles used to be, but get my chrome jacket. Yeah, that's actually not looking too bad there. I think Mr. Microphone is still poking through the hole in the chrome jacket. Knock those corners off. I've got a really, really good weld on my puller. I'm going to start building my core heat. Using the NQALHA, and then switch to handwork for the final pull. I have ideas for pulling on the NQALHA, but so far haven't actually successfully done a pull on the NQALHA yet. I do have some twist in the piece. I'm focusing my heat on the end, because I'm going to start pulling from the left end here. I want to try to get as much usable material as I can get. I'm trying to remove some of the twist by hand, but my hand skills are unfortunately rather poor, even without gloves. The master pullers make it look so easy, and I can tell you there is nothing easy about pulling. The guys that are good at it make it look like, oh, no problem, you just heat it up and you pull it perfectly straight, almost no knuckle. And I try it and, wow, this is hard. Although I do continue to get better at it. I'm not going to go back and try to dick with the left knuckle. The material isn't really that good. And if I cared, yeah, I'm just going to call that as good as it gets. And that is the pull. Into the kiln it goes. be very interested to see how this guy looks. Of course, this is going to be a component in a somewhat more complex assembly, so probably for the next video I'll be doing the more complex assembly that this is a component of. So hey, thank you for watching. It's been fun and really hot and really hard. Maybe that's why I like it so much. Not the hot part.